Hey, hello students. In this video, we are discussing further about the angles, more about angles in trigonometry. Now, in trigonometry, what is the standard position of an angle? What is the standard position of an angle? See, for the standard position, we consider the coordinate plane. Suppose this is your coordinate plane. So this is origin and x-axis and y-axis. What we used to do in standard position, we can consider vertex at the origin and the initial ray is along the positive side of x-axis. Suppose this OB1 is the initial ray, and suppose this is rotated through an angle, say theta, in anticlockwise direction to obtain the terminal ray. So this is the standard position of the angle. Now, where this terminal ray lies, the terminal ray lies in the first quadrant. So address of the terminal ray is the first quadrant. So here theta is known as angle of first quadrant. First quadrant. Now suppose if we rotate this initial ray through an angle theta 1, suppose this is theta 1 and here is the terminal ray, then here theta 1 is known as the angle of second quadrant. Now see how you will see the address of the terminal ray. So address of the terminal ray is theta 1 is angle of second quadrant. Suppose we have a ray in third quadrant. Suppose initial ray is rotated through an angle theta 2. So here theta 2 is known as angle of second quadrant. By similar argument, suppose if our terminal ray is in the fourth quadrant and suppose this is rotated through an angle theta 3, then theta 3 is known as angle of fourth quadrant. Okay. Now what will happen if the terminal ray falls on one of the coordinate axes? That is, if a terminal ray falls on the one of the coordinate axis, then it is known as quadrantal angle. Then it is known as quadrantal angle. See, if I make a figure, suppose this is your coordinate plane and here is the origin. Now suppose if the terminal ray and the initial ray coincide, then this is theta equals to 0. Now if the terminal ray falls on the positive y-axis here, then this angle is pi by 2. Now if the terminal ray falls on negative x-axis, then this angle is 180, that is pi radian. If the terminal ray falls on the negative y-axis, then this angle is 3 pi by 2. Now suppose if a terminal ray take one complete rotation, then this angle is 2 pi. So can we say that quadrantal angles are nothing but integral multiple of pi by 2. So quadrantal angles are nothing but integral multiple of pi by 2. Now the next important concept is coterminal angles. What do you mean by coterminal angles? Now the coterminal angles are the angles in which the terminal ray at the same position, that is coterminal angles, that is terminal ray, coterminal angles are those angles in which terminal ray at the same position. Now let us understand it. Suppose this is your coordinate plane. Suppose this OB1 is your initial ray, and suppose this is rotated through an angle theta to obtain this terminal ray. Now please tell us that is it the only terminal ray for which we have obtained this theta? So we have infinitely many angles which has the terminal ray. Say this is OA. So for instance, we can take one complete anti-clockwise turn to obtain this angle again. So now what is the measure of this angle? Measure of this angle is theta plus 2 pi. Now we can have 2 turn. Then what is the measure of this angle? Theta plus 4 pi. Now in this way, suppose if I take one more term, then what is the measure of this angle? Theta plus 6 pi. So in this way, we can obtain theta plus 2n pi. Now we have another argument. We can take clockwise rotation as well. Suppose here is the angle and this is your terminal ray which is rotated through an angle, say theta, and this is your initial ray along positive side of x-axis, say OB1. Now we can reach to this terminal ray by taking clockwise rotation. Now what is the absolute measure of this? Absolute measure of this angle is minus times of 2 pi minus theta. We can also obtain this by taking 2 turn. Then what is the absolute measure of this angle? Absolute measure of this angle is minus times of 4 pi minus theta. So in this way we can say that the angles can be theta minus 2 pi, theta minus 4 pi, and theta minus say 2n pi. So in general I can say that we can write for a particular angle theta, so that we can write infinite coterminal angles by using the expression theta plus 2n pi, and this n is any integer and can be positive as well as negative. So for a particular angle we have infinitely many coterminal angles. So this is the by this expression we can write all the infinite coterminal angles. Now for instance, if you see our quadrantal angles, you know that this is theta equal to 0. Now all the coterminal angles corresponding to this, that is 0 plus 2n pi. Now suppose if your quadrantal angle is this, so how we'll write this? Because this angle is pi by 2, so all the infinite coterminal angles can be written as pi by 2 plus 2n pi. We can write this as 4n plus 1 times of pi by 2. Similarly, if the terminal ray falls on the negative side of x-axis, then this angle is pi. So all the infinite coterminal angles given by the expression pi plus 2n pi. We can write this as 4n plus 2 times of pi by 2. Similarly, if the terminal ray falls on the negative side of y-axis, the absolute measure of this angle is 3 pi by 2, but all the infinite coterminal angles given by, simply add 2n pi to this. So we can write this as, if I take pi by 2 common, so it is nothing but 4n plus 3 types of expression. And for this we can write this as 4n times of pi by 2. Now see, so you can see that all the coterminal angles are nothing but or of the type that is 4n into 4n types, that is 4n, 4n plus 1, 4n plus 2, and 4n plus 3. See, when you divide any number by 4, so we obtain only these 4 types of numbers. You can understand it like this. Suppose if there is a number m, and if you divide it by say 4, then here is the quotient and here is the remainder. Then how you can write this number? This m can be written as 4q plus r. Now what are the possibilities on the remainder? Remainder can be 0 but less than the divisor. Now see, when this r is 0, your number is 4q type. When remainder r is 1, the number is 4q plus 1. When it is of the remainder is 2, so number is 4q plus 2 types. And when remainder is 3, so number is 4q plus 3 type. Now similarly, your quadrantal angles, that is all the infinite coterminal angles, follow the same rule. So I hope you have understand the concept of coterminal angles and the concept of quadrantal angle in this video. Thank you for watching this video.